Mario once again. In this video I am going to show you how I am installing these blades, 3D printed blades. I mentioned in my other video that I did today. By the way, today is Thursday, January the 22nd, 2026, and these are my 3D printed blades, printed at 0.1 millimeter layer thickness, and you can see compared to the original one. This one is printed also with a height of 2 millimeter to establish the proper stiffness. This is very similar in stiffness to the to this maybe just a little bit, just a tiny little bit stiffer than this injection molded ABS blade. I also did this hole larger than the typical hole because, as I mentioned in my other video, that is to introduce damping on the blade grip. This height also is lower than the original blade. If we were to compare both blades right here, this blade is a little bit higher than the thickness is a little bit higher than this one here, and so this one with the O-ring is going to fit inside there, and you can see it's got some play there, deliberate play. I designed it that way so that I can introduce damping, as I was saying, via an O-ring. This is an O-ring. It fits like that. And so that provides a little cushion, if you will, or damping is the proper terminology for that, on the blade grip. As you can see here, I just installed that with a screw, the original screw, not tightening this too much. This has to have some movement here. It's got to pivot freely. You don't want these blades tight, because then the rotor, there's no point in having damping there, because then the rotor starts doing this, very abruptly, boom, 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 starts shaking, not shaking, but when you control it, it's very abrupt changes like that, and you don't want that. You want a very smooth operating rotor head. And the way to get it, partially to that point is to to nice and smooth. You want that thing to flow and be very reactive as well. Is to put a little bit of damping on the blade grip. It would be great to have damping here, some kind of a universal damping on the head itself, so that it's it dampens the rotor head in all directions. But since we don't have that, since this head is not feasible to do that, at least not without redesigning the complete rotor head, I just decided to do this on the blade. As you see it right there, you can see that, and that O-ring provides some cushion to that. I can tighten this just a little more here. The point is not to tighten this to where it locks the blade. This has to have a little bit of give here. Not too floppy, but not excessively tight. You want this nice and smooth, just like that. So, I just wanted to capture this in this video, and I'm going to continue to do the rest to the other blades. There's no point in me continuing to do this on this video, because I've already done one, and you can just imagine I have to do the same for the 1, 2, 3, 4, the rest of the 4 blades. So that's MIA Microflight's solution for a much smoother head design. This idea here is an idea that I employed actually on some of my early some early helicopters that I did back in around the late 80s, early 90s. I was already playing with some of these mechanical components, and just doing a lot of experimentation back in those years. I mean, I've done so many rotor heads. In another video I will show, as I am showing some of the old stuff that I have done. The history on a lot of my helicopters, the way the way I developed them. I've been showing that also in some regular videos. You can watch those videos, and I'll probably show some of those mechanical contraptions that I did. I did countless mechanical contraptions in order to understand and fully have a grasp on what works and what doesn't. So this is nothing new, but it is one of my own designs and my own approach to a blade grip with damping on the blade grip bolt connection. Mario, once again, stay tuned for more.